I am Battula Rajeshwari. I am currently pursuing BTech third year at Annare Institute of Technology, Agripalli, in the branch of Electronics and Communication Engineering. Today I am presenting about microwave oven simulation using PIC microcontroller at Emertxe company. Introduction to Internship. This presentation describes the learning and practical experience gained during the Embedded Systems Internship conducted by Emertxe. The internship was designed to provide a strong foundation in embedded systems, combining theoretical concepts with hands-on implementation. The program began with Embedded C programming fundamentals, followed by embedded system basics and microcontroller concepts. Emphasis was given to understanding the interaction between hardware and software in embedded application. The internship included practical sessions on peripheral interfacing such as LEDs, switches, keypads, timers, interrupts, and character LCDs. Development and simulation were carried out using industry standard tools like MPLAB XIDE, XC8 compiler, and PICSimLab. These are all simulation softwares to develop the programming of microcontroller boards. A structured project-based approach was followed to integrate all the concepts learned during the internship. The internship also included career-oriented workshops such as resume building and embedded systems career guidance. About Emertxe company. Emertxe is a professional training and skilling organization that provides industry-oriented training in embedded systems, IoTs, and Linux systems. The training methodology at Emertxe follows a structured approach where concepts are explained theoretically and reinforced through hands-on practice. This approach helps students understand real-world embedded system development. The main objective of the internship is to gain practical knowledge of embedded C programming for microcontroller based applications, to study the architecture and features of microcontrollers, particularly the PIC microcontroller used during the internship, to learn peripheral interfacing techniques including LEDs, switches, keypads, timers, interrupts, and character LCDs, to develop skills in using industry standard development tools such as MPLAB XIDE, XC8 compiler, and PICSimLab, to implement and demonstrate an embedded system project integrating multiple peripherals. What do you mean about embedded system? An embedded system is a combination of both hardware and software. It performs a specific task during a real-time operating systems. There are two different types of operating systems: general purpose operating system, real-time operating system. Real-time operating system is a crucial because it helps to develop a crucial things. Unlike general purpose computers, embedded systems are task specific and optimized for a particular application. An embedded system consists of microcontroller or microprocessor, memory, input or output peripherals, and embedded firmware. Firmware is nothing but software. The software used in embedded systems is known as firmware, which directly controls the hardware. How to control the hardware? By using device drivers. Device drivers is nothing but it is used in to communicate the hardware device with exactly using the software. These systems are designed to be reliable, efficient, and cost effective. Embedded systems are widely used in consumer electronics, automotive systems, etc. Applications of embedded systems. Embedded systems are widely used in consumer electronics such as microwave ovens, washing machines, air conditioners, and televisions. In the automotive industry, embedded systems are used for engine control units, anti-lock braking systems, airbag control, and dashboard monitoring. In industrial automation, embedded systems control machinery, robotic systems, conveyor belts, and process control units, etc. There are different components of an embedded system: microcontroller, microprocessor, memory, input devices, output devices, peripherals, power supply, embedded software. Microcontroller microprocessor is nothing but central processing unit of the embedded system. It executes the program and controls all system operations. Memory is nothing but it is a storing element to store variables during program execution. It may be ROM or RAM. ROM is nothing but permanent memory. RAM is nothing but non-volatile data storage. Input devices. Devices is such as switches, sensors and keypads that provides input signals to the embedded system. Output devices. Devices such as LEDs, relays, motors, buzzers, displays that provide output or system status to the user. Peripherals is nothing but analog to digital converters, timers, interrupts, communication interface like SPI, I2C. These are all called communication interface. And interrupt controller that enhance system functionality. Power supply requires operating voltage and current to the embedded system components. Embedded C programming overview. Embedded C is a programming language used to develop software for embedded systems. It is based on the C language but provides features for direct hardware interaction. Embedded C focuses on efficient memory usage, fast execution and reliable control of hardware peripherals. Embedded C concepts studied. Understanding the structure of an embedded C program, use of data types and variables, implementation of control statements, writing modular code using functions, use of pointers, application of bitwise operators, understanding and use of preprocessor directives, interfacing GPIO pins, writing delay routines using timer instead of software delay loops, implementing interrupt based programming. Embedded system development flow. Requirement analysis, system design and architecture, hardware and software partitioning, firmware development, completion and build process. There are 5 steps to develop a embedded system flow. And again there are 3 steps: simulation and testing, debugging. Debugging is nothing but finding errors and correcting the errors, final implementation and validation. Requirement analysis is nothing but to identify the problem and system requirements such as functionality, performance, input output needs, real-time constraints. System design and architecture is nothing but the overall system architecture is designed, including selection of microcontroller, peripherals, power supply and communication interfaces. Hardware and software partitioning. The system functionality is divided into hardware and software components to ensure efficient implementation and optimal performance. Firmware development. Embedded C code is written to implement the required functionality. This includes writing drivers per peripheral like LEDs, switches, timers, keypads and displays, etc. Introduction to microcontroller. A microcontroller is a compact integrated circuit designed to control specific operations in embedded systems. It consists of a CPU, RAM, ROM or flash memory, input-output ports, timers and interrupt systems integrated on a single chip. During this internship, we used the PIC16F877A microcontroller for learning and implementing embedded system applications. It is an 8-bit microcontroller from Microchip, widely used in educational and industrial embedded projects. It integrates the CPU, memory, input or output ports, timers and peripherals modules on a single chip. It supports efficient embedded C programming and easy peripheral interfacing. Microcontroller architecture. It follows a RISC architecture. RISC is nothing but reduced instruction set computer, which follows fast instruction execution. The microcontroller is based on Harvard architecture, where program memory and data memory are separate, enabling efficient data access. It integrates CPU, memory, input or output ports, timers, analog to digital converters and communication modules on a single chip. It is very suitable for real-time embedded applications. Here we are observing microcontroller architecture. There are different types of timers, arithmetic logic unit, BIU, bus interface unit, execution unit. There are different types of registers, flag registers, general purpose register, data data conversion mechanism, etc. Input or output ports and peripherals. It provides 5 input or output ports for interfacing external device. Each port pin can be configured as input or output using direction registers. The microcontroller includes timers, timer 0, timer 1, timer 2 for delay generation and time-based control. The ADC module allows conversion of analog signals into digital values. Built-in interrupt system enables real-time response to external and internal events. There are different types of clocks by generating an oscillator to generate a new pulse signal to the system. The clock frequency determines instruction execution speed and timing accuracy. The interrupt controller manages multiple interrupt sources such as timers, external interrupts, and peripheral interrupts. It supports communication modules like USART, SPI, PC, enabling data exchange with external devices. USART is nothing but Universal Synchronous Asynchronous Receiver Transmitter. SPI is nothing but Serial Peripheral Interface. PC is nothing but Program Counter. These features make the controller suitable for real-time and communication-based applications. There are different types of simulation softwares. MPLAB X IDE was used as the integrated development for writing, organizing and debugging embedded C programs. PIC-SimLab was used as a simulation tool to test microcontroller programs and peripheral behavior without using physical hardware. PIC microcontroller datasheets were used as reference documents to understand pin configuration, registers, peripheral operation and timing details. Windows operating system was used as the development platform for running all embedded development tools. It is a microcontroller simulation software used to simulate and test embedded system applications without using physical hardware. It provides a virtual environment where microcontroller programs written in embedded C can be executed and analyzed. The tool allows real-time interaction with peripherals, enabling observation of system behavior where inputs are applied. Now we have observed PIC-SimLab simulation interface. There is a board, there is a similar types of connections like fan, rotating clock pulses like giving inputs 1, 2, 3, 4, 5. By clicking on inputs there is a milliseconds or nanoseconds or seconds. So many ICs are developed in on one chip. Introduction to peripherals. Peripherals are external hardware components connected to a microcontroller to perform input, output or control operations. Peripherals enables interaction between the embedded system and the user or environment. During this internship, peripherals were interfaced using PIC16F877A microcontroller and tested using PIC-SimLab. Matrix keypad. Keypad is nothing but there are different types of numbers and it is operated by switches, rows and columns. Character LCD. LCD is nothing but liquid crystal display. Is an output peripheral used to display alphanumeric characters in embedded systems. The most commonly used CLCD is 16:2 LCD, which can display 16 characters per line and 2 lines of text. CLCD are widely used to display system status, messages, sensor values, and user prompts. ARS register selects command or data register. RW reader byte select reader byte operation enable latches data into the LCD. CLCD can operate in 8-bit mode or 4-bit mode. 8-bit mode is nothing but it uses 8-bit data lines and it is faster. 4-bit mode is nothing but uses only 4-bit data lines and saves GPIO pins. CLCD interfacing helps in understanding data communication, command execution, and display control in embedded system. Now we are discussing about tactile system. A tactile system is a commonly used momentary push button input device in embedded systems. It provides a temporary electrical connection only when the button is pressed. Tactile switches are widely used for user input such as mode selection, reset operations, and control commands. When the switch is pressed, the logic level at the microcontroller input pin changes from low to high or vice versa. Fan. A fan is an output actuator peripheral used in embedded systems to provide cooling, ventilation, or airflow control. Fans are commonly used in applications such as temperature control system, electronic equipment cooling, and home automation. In some applications, PWM pulse width modulation is used to control the speed of the fan. Now we are discussing about timers. Timers is an internal hardware peripheral of a microcontroller used to measure time intervals and generate accurate delays. Timers are widely used for delay generators, periodic task execution, event timing, and real-time control. Timers can operate in different modes such as timer mode and counter mode. Interrupts. An interrupt is a mechanism that allows a microcontroller to temporarily stop its current program execution and respond immediately to an important event. Interrupt enable the system to handle time critical tasks efficiently without continuously checking for events. Interrupts occurs when an interrupt service routine is on. We have observed about block diagram of microwave oven. Now we are moving to project demonstration. Is nothing but first we identify the program procedure by giving the program to develop a output of the microwave oven. We are observing project demonstration. Is nothing but program of a code to develop microwave oven. And we are moving to PixSimLab. Here there are 4 conditions: micro, grill, convection, start. By using these 4 conditions, we have to control the micro oven. In first condition, micro, by dumping the code, power line on microwave oven. Power is 900 watts. And we have to set time equals to clear and enter. Set the time by clicking on number 8, time equals to 8 seconds. Here we have to start and pause and stop. There are 3 conditions. First we have to start the condition. After 0 seconds, we have to complete the time up. And again we have to choose any time seconds to pause and stop. And we will set a temperature like 180 degrees Celsius or anything. Preheat line time up. Here we have to control the fan also. So we have to observe the 4 conditions in Peak SimLab software. Here we have learned so much things at Emertxe company. So we are very proud to say to learn new things like embedded systems basics, programming languages and simulation softwares. These are all very useful to develop a new applications or gaining a new experience. Thank you.